Guys, good morning.
Good morning.
Alright. And in today's class, we are going to look at sketching quadratics. In previous lessons, we have been doing some work in algebra. We have been doing some work in sketching linear graphs. Well, I'm not going to say I assume that you guys have mastered that, but you guys have what is needed to do the sketching of quadratics now. And today we are going to look at sketching, and we're going to look at an example. I'm going to be asking most of the questions in this class. You are going to ask most of the questions, unlike other classes. You are going to ask most of the questions. I am going to ask some questions, and I'm going to direct the questions to certain persons in particular. And let's look at this. An example. Sketching quadratics. To start with, who can tell me what's a quadratic? What is a quadratic?
As x with an exponent of 2.
What is a quadratic? That's a fundamental question. You guys must answer yourself. What is a quadratic? And you must answer yourself. It's a function with the x power being the highest x power. It's a polynomial where the highest power of x is 2. That's a quadratic, right? So it will take the form of f of x is equal to ax squared plus bx plus c. You guys should recall that? Can you relate to that equation? Okay, so we will start with an example being y is equal to y being f of x or h of x, whichever way you want to take it. H is equal to x squared plus 7x plus 12. Looks like a good example to use, Mr. Romero? Yeah? Alright. So we're going to look at this quadratic in particular. If you recall from linear functions, guys, and what was needed to sketch a linear graph? For instance, we have y is equal to mx plus c, which is y is equal to mx plus c, which is the general equation of a straight line, the general equation of a linear function, y is equal to mx plus c. What did we use to sketch the linear function? What did we use? Mr. Britannia?
The constant and then the gradient.
We had the knowledge of the gradient, which is represented by the m, and c, the constant. Can you tell me anything about the constant, Ms. Amir, on the linear function? What is the constant?
The constant is where the function has been left.
Okay, the constant is actually the y intercept. It is actually the y-intercept. Now, you can recall that to sketch line graphs, we only need 2 points. And what are the easiest 2 points to find? We know one already, right? The y-intercept. Which is the other point we can find? The x-intercept. How do we find the x-intercept, Mr. Romero? Let y equal 0. We go back to our function. Y is equal to mx plus c, where y is 0. Then x is equal to negative c over m. Good. Now, if we have a quadratic here, y is equal to x squared plus 7x plus 12. Good? We have a quadratic there. What would you think we need to sketch this quadratic? What would be the things you'd be looking for to sketch? If the fundamentals tell us that the y-intercept and the x-intercept are key features of a function, what do you think we will need to find it in order for us to be able to sketch that quadratic? Yes, Mr. Hussain.
We need to find the x and y-intercept of the quadratic.
Okay. Good. We find the x-intercept, but we also find the y-intercept. How do we find the x-intercept? Nothing. How do we find the y-intercept? How do we find the x-intercept? What must we do? Okay, in this case we make y equals 0, and in this case we make x equals 0. Questions, Mr. Romero? No? Okay. Now we're moving on. Which one? Who wants to volunteer to do any of these?
That is the y-intercept.
Okay, I thought you would say that. You'll do the y-intercept. We go back to our original function, right, Mr. President? Y is equal to x squared plus 7x plus 12. Where x is equal to 0, then y is equal to?
We need to substitute the 0 for the
Good.
x.
So we have 0 squared plus 7 times 0, 0 plus 12, which gives you, Miss Leslie, 12. We now know the y-intercept. Now, you ran away from this one, Mr. Briseño, but I know Mr. Romero is willing to do this one for us, or at least guide me through the process.
The function will be
0, right? So 0, but we go back to, we rewrite this function. Since y is equal to x squared plus 7x plus 12, when y is 0, 0 is equal to x squared plus 7x plus 12. Now, there are at least 3 ways that you guys can solve that quadratic. There are at least 3 ways that you guys can solve that quadratic. One way, Mr. Briseño.
Using factorization.
Okay, you know how to solve quadratics using factorization. Miss Marie? Using the quadratic formula. Mr. Romero? Completing the square. Good. Now, which method would you opt to do first? Which one would you try to do first? Factorizing. Because it's usually the easiest one. It's the easiest one and the fastest one, right? But sometimes there are some of these that cannot be solved by factorization, and then is where we do either completing the square or quadratic formula, which are essentially the same. Okay, now here, can this be factorized? Yes. 2 numbers that when multiplied give you
The constant.
the constant, and when added give you the coefficient of x. The coefficient of x. Now, I must remind you guys of this again. That you need to find 2 numbers that when multiplied give you 1 times 12. It's not just 12, but it is 1 times 12. You always use the coefficient of x squared and you use the constant. So you need 2 numbers that when multiplied give you 12, when added give you plus 7. What are the 2 numbers? 4 and 3. So the 2 factors are going to be x plus 4 and x plus 3. Excellent. Let's move on from there now. We know that 0 or x plus 4 quantity multiplied by x plus 3 quantity equals 0 implies that either x plus 4 equals 0 or x plus 3 equals 0. In which case we find here that x is equal to negative 4. X equal negative 4 and x equal negative 3. What are these then? we have 2 points now. Can we sketch the graph with 2 points? Now, you must remember that the shape of the quadratic is not a straight line. The shape of a linear function gives you a straight line, but a quadratic will not give you a straight line. It's a curve. It's a curve. And what do you know about curves? What do you know about curves?
They can have the shape of a U or an inverted U.
Okay. Shape of the graph. A quadratic y is equal to x squared plus 7x plus 12. Mr. Briceño is saying that the shape can be of 2 types. One, it can be shape of a U, or it can be the shape of an inverted U. When will it have the shape of a U? When is it going to have the shape of a U?
When it's positive,
When what is positive?
the coefficient of
The sign of the coefficient of x.
When the coefficient of x squared is negative. Agree?
No.
No? Thank you very much. When the coefficient is positive, but I was going to read, but there is no need. Okay. So it is going to have an inverted U shape when the coefficient of x squared is negative. Mr. Romero was saying when the sign of the coefficient of x squared is negative, when it was positive, but it's the same thing. It's essentially the same thing. The sign determines the positive or negative of the constant itself, coefficient itself. Okay. So keeping this in mind, our quadratic will have what shape? A U or a inverted U shape? U. So this is going to yield a U shape. So we know 3 things so far. We know the U, we know the x-axis, the x-intercepts, and we also know the y-axis intercept. So we know it's going to cut 3 places, and we know the shape. What else do we need?
Maximum, either the maximum or
Okay. You need to know how far.
the maximum.
Is it a maximum? Can it be a maximum that we're looking for?
No.
No. What is it going to be?
Minimum.
It's going to be a minimum. This yields, this yields a minimum, and this yields a maximum. Because why maximum? Because that's the highest point that it will have. This one is the highest y value it will have. Highest y value, lowest y value, minimum, maximum. Questions? You guys have any questions so far? Yes, Ms. Nelson? You understand everything so far? Are you sure? Okay. Let's move on then. Here, it will have a specific value. Here, it will have a specific value, and here it will have. How far does it go? We don't know that. But that's important information. We need to know that in order for us to be able to sketch the graph. Therefore, we go back to previous knowledge. We go back to the knowledge of the gradient of a graph. You know that a curve has gradients, different gradients at different points, given by the tangential at that particular point. If the tangent was here, then you would have a gradient of delta y over delta x. If the gradient was found there, it would have a different gradient. So at different points it will have a different gradient. Now when we go back to linear functions can have that shape. In which case the gradient is? In which case the gradient is?
negative
In which case the gradient is?
0,
0. And here, in which case the gradient is? Undefined. We don't know that. Okay, here, this is key. The gradient is 0 for a horizontal line. Now, where be a horizontal line? Yes, Mr. Romero? At the minimum, at the lowest point, the gradient would be equal to 0. Amir, if the shape of our graph was like this, an inverted U shape, where will the gradient be 0?
Maximum.
At the maximum point. Right? So that's important information. At the minimum and at the maximum, the tangential line is a horizontal line where the gradient is 0. Good? Okay, from there, do we know the gradient of the line of the curve at any given point of this particular curve? Do we know the gradient at any given point? Do we know the gradient at any point? Do we know the numerical value of the gradient at any point within the curve? We just went through it.
Yes.
When will the gradient be 0? At the minimum point, because the coefficient is positive. At the minimum point, it's going to be 0. Now, do you guys have any idea on how you find the gradient function of a quadratic?
You need to differentiate.
Good. If we have that y is equal to x squared plus 7x plus 12, you are saying the differential yields the gradient function. Delta y delta x is always going to give you the gradient function. Now if we go back to y equal mx plus c, what's the differential of this particular function? What's the differential? M. And that is the gradient function. However, in this case, the gradient function is actually a constant. It's not in terms of x. So we know the gradient. And how? Why does it give you a constant? Why does it give you a constant? Why don't you get an x value there? Thinking about the graph. Because it's a straight line. Because it's a straight line which has one gradient. The gradient cannot change. It is always the same. That is why it gives you a constant. However, in a curve, the gradient will be different at different points. So therefore here, we are not going to get a constant, but we are going to get a function. A function in which the gradient will be different for different values of x. So let's differentiate this Maureen. I know you're good at that.
2x plus 7.
2x plus 7. That is the gradient function of our original graph. Good. Now, do we know the gradient at any given point? Yes. Where? Where? At the minimum? What's the gradient? 0. So we substitute that. 0 is equal to 2x plus 7. In which case, Mr. Presenio, x is going to be what?
7 over 2.
Good. 7 over 2. X is equal to.
Negative.
Thank you very much. When you subtract 7 from both sides, you put a negative there. You put a negative. Good. Thank you guys. Questions so far? Miss Messi? Leslie? You have any questions? Guys, you guys are a bunch of smart people, you know. Good, you're making my job very easy now. Alright. So we know the x value of the minimum. We know the 2x intercept where it's going to cut the x-axis. We know the y-intercept where it's cutting the y-axis. What is missing? Can we plot the minimum point?
We're missing the y.
We are missing the y value for the minimum coordinate. So how do we find the y value?
We substitute the x value
We substitute the x value
to the original
into the original equation. Thank you very much. Y is equal to, what's the original equation?
X squared plus 7x plus 12.
Plus 12. We are going to substitute this guy in there. So we have minus 7 over 2 squared plus 7 minus 7 over 2 plus 12, which gives you, what is it here? 49 over 4 minus 49
over 2
over 2
plus 12.
plus 12. What does that give you?
Negative 49 over 2 plus 12.
That's true. Negative 49 over 2 plus 12. But we have to remember that 49 over 2 is what? If you put that as a mixed number. Yes, miss. Yes, Mr. Michael. I'm glad you are doing that. I'm glad that you went back to your old friend.
12.5.
But still your old friend is not helping.
Negative 12.5 over 4.
What? What? Minus 12.5 over 2? Look at this. Look at the ease of this. You did the right thing here, Mr. Bresenio. 49 over 4 minus 49 over 2 gives you, just looking at the two fractions,
49 over 2.
it gives you minus 49 over 4. Minus 49 over 4. But 49 over 4 is 12 and 1/4. Minus 12 and 1/4. Minus 12 and 1/4. Plus 12
Negative 1/4.
minus 1/4. Minus 1/4. Yeah, you have to become more familiar with your old friend there, Mr. Michael. Okay, so this is what? The y or the x value?
Y.
The y value. That's a y value. Now, do we know the minimum coordinate? The minimum coordinate is what? Negative 3.5 minus 1/4. That is the minimum coordinate. Now we know the minimum coordinate, we know the y-intercept, we know the x-intercept, and we know the shape of the ground. So let's sketch. That's all we need. Y, x. Good. Where do we have the x-intercepts? X-intercepts are at minus 4 and minus 3. Y-intercept is at 12. Minimum is at, where is minimum? Minus 3.5.
Negative 1/4.
Negative 1/4. So it's going to be relatively close to the x-axis, right? 1/4. So the minimum is going to be somewhere around there. Minimum is here. This is where it cuts the x-axis. This is where it cuts the y-axis. There we go. And that is our graph. This is the graph. Y equal x squared plus 7x plus 12. Any questions? Right? Do you have any questions? No? If you don't have questions, I have questions. If you don't have questions, I have questions. What can you tell me about the symmetry? What can you tell me about the symmetry of the parabola?
It's symmetrical at the minimum value where x is equal to 3.5.
At at the line
3,
at x equal
3 and negative 3.5.
this is the line of symmetry.
Mommy?
What does line of symmetry mean, Miss Amira? Miss Marine? What does that line of symmetry mean? What is that saying?
Like half of the
Ah? Yeah? I understand your point. It's like half. Yeah, something related to that. Yes.
Being the inverse of the next one.
It's the inverse.
No, it is showing that it can be having the
In theory, I believe that it's like you can pull the two parts and they will match, which means that this side is a reflection.
Thank you, Mr. Brazilian. Thank you. And you specify in theory. Because in my sketch, it does not look symmetrical, does it? And you specify in theory that this will be the mirror line. This will be the mirror line. If you were to fold this, you will have the points falling exactly in the same points. That's what line of symmetry actually means. Now, do you guys feel ready to do a sketch?
Yes.
Okay, let's do an example then. I think you guys were taking notes of each and every section. Because right now you are going to prove yourself. Good. Let's look at this. I want you guys to sketch the line y is equal to x squared minus 2x minus 15. Okay. Let's make it this way. You guys are going to guide me through the process. I am not going to do anything unless you tell me to do so. Good? And then on the third one, you guys will do it on your own. Okay. I'm reading.
We need to find the x and y intersection.
But let me remind you guys of one thing. There is no class consisting of one person, right? So I want you all to cooperate. Good? Alright. The x-intercept and the y-intercept. The y-intercept and the x-intercept.
So for the first x, you have to making it
y equals
y
0.
What happened? Y equals 0. But y is equal to?
the x
X
squared
squared minus 2x minus 15. So
So
these
0.
are 0 equals to x squared minus 15. For the y-intercept,
Are we finished here?
We
we
need
can
to
find it by factorizing
What are we going to find?
the x-intercept.
The x-intercept. In this case, we are going to find the roots of the square, right? The quadratic, the roots of the quadratic. So, can you factorize? Can you do it mentally, or do we need to write the process? Can you do it by inspection? Two numbers when multiplied. You tell me. What do we need?
Two numbers that when multiplied gives you negative 15 and when added or gives you negative 2.
That's the need, right? What are those numbers?
negative 5 times 3.
Do you guys agree?
yes.
Okay. So we have, what are the roots?
So the x minus 5
Minus 5x plus 2.
Thank you. And?
and then we have to it is saying that either x minus 3 minus minus 5 is equal to 0 or x plus 3 equals to 0.
From there we can solve for x.
So x equals 5 and x equals negative 3.
Was someone there saying negative 5? And is it clear how we got the positive 5? Because you equate to 0. When you add 5 to both sides, you end up with positive.
X equals negative 3.
Oh, thank you. I see I have a negative, but I don't have an equal. Yeah. Good.
So next one is divide, finding the y-intercept.
Remember guys, I need you all to cooperate here. It's not just Mr. Romero.
For the y-intercept, you make x equals 0, which is y equals 0 squared minus.
Well, let's just rewrite the function first. What x equals 0, so y is equal to? Oh yes, 0 squared.
Minus 2 times 0 minus 60, which makes y equals negative 50.
You can. What do we have there?
The x-intercept and the y-intercept.
We have where it cuts the x-axis and where it goes the y-axis. Now, listen. What do we do next? We found the x-intercept, we found the y-intercept. Good.
The shape.
Okay, the shape of the graph. Mr. Briseño, tell me.
Since the coefficient of the x term of the x squared is positive, that means that the shape of the parabola will be that of u, of IU.
That's what Mr. Briseño is saying. So far we know shape where it cuts the x-axis, where it cuts the y-axis. What is missing now, Mary?
The gradient. We know that the gradient of the
So what are we looking for? We're looking for? Yes, Mr. Romero? Looking for? We're looking for the minimum or so you can.
So we know that the minimum is finding the gradient will be parallel to the x-axis
The gradient
of the minimum. Or the point of that point will be the
the
parallel.
gradient at the minimum will be
Parallel to the x-axis. So
which is
0.
0. So the gradient at the minimum is 0. I agree with you.
So we
How does that help?
we will be differentiating the original.
The original function
is
we differentiate.
so it is
Hey,
twice.
just hold on, Mr. Romero. I want to hear from Mr. Briseño. Tell me, Mr. Briseño.
It will be 2x minus 2.
Thank you. What do we do next, Miss Marie? What do we do next?
since we have that the differentiation of the original function is 2x minus 2, we find the value of x.
We find the value of x. You see, since we know that differential is 2x minus 2, we find the value of x. Can we find the value of x of that? How do we make x the subject? Okay. X is equal to
2 over 2.
stated there that the gradient is equal to 0. And that is equal to 0.
So this is equal to 0. So we know this, but we also know this, and we have to use both, right? Now, could you have done it like this? If y is subject and then substitute for dy dx? Now, you are telling me to do this, Mr. Romero. 0 is equal to 2x minus 2, x is equal to 1. We solve for x, right? Now, could we have taken this and make x a subject, and then afterwards substitute? Yeah, would it have given you a different answer? No, it would have given you different. So, we know the x value for minimum, but you have to remember that minimum coordinate consists of
X and Y.
X and y, and we have the x. Now, the original equation is
x squared minus 2x minus 15.
so, Miss Marie.
Substitute the x equals 1.
Okay, well, x equals 1, right? Y is equal to
1 squared minus 2 times 1 minus 15. 1 minus 2 minus 15.
16.
Negative 16.
We know that the minimum coordinate is going to be 1 minus 15. Now, are we finished? Where is the sketch then? Okay, we have to sketch now. Okay, we were doing more to gather information that will help us in the sketch, but we need to do the sketch. If you finish, if I ask you guys for the sketch, you're going to give me all this work, you are definitely not going to get full marks. Because I don't see the sketch. Okay. Yes. You tell me.
Partition.
Cartesian axis.
We got the points.
Okay, okay.
X and Y. So this is
5 and
So it's going to cut the x-axis at 5.
and negative.
Like that. Negative 3.
So from the unknown dy, which is a 15.
15. Negative 15 here.
So we covered
How is it?
Now, the minimum point.
now to plot the minimum
Okay, minimum is that?
and negative 16 y. Y is x
x
equals
is
1
1.
and
Y
y is
negative
16.
Minimum. Now drawn. You know, sketch, right? That's the easiest thing to do. That look right? Y is equal to
X squared minus 2x minus 15.
now. What is the equation of the axis of symmetry?
1 and the value for x would be 1 and then for y it would be negative 16, which is the minimum point. The line that runs there being parallel to the y-axis.
The equation of the line. I agree with you that the axis of symmetry is going to pass through this coordinate, which is 1, negative 16. I agree that the line of symmetry is going to pass through that. But what is the equation of the line of symmetry?
X equals 1.
Negative.
The equation of the axis of symmetry is x equal 1. Questions? Easy, right?